Good evening. As we wait for Dr. Callahan to return to the room, I'd like to welcome you to Edison High School in the Huntington Beach Union High School District. I'm Connie Mayhew. I'm the Executive Director of Curriculum Instruction. And Dr. Callahan has been working with our teachers over the last year as we transition into Common Core. He officially is the statewide co-director of the California Mathematics Project through UCLA. He comes to us with a wealth of knowledge and a wealth of opportunities. And he's here to provide some information for you. So I'd like to turn it over to Dr. Callahan.
Thank you so much. It's a pleasure to be here, and thank you. I know coming out on a Monday night, especially in the rain, is not easy, and everyone has busy schedules. So I'm going to try to be as helpful as possible and save some time for questions and get us on our way. And again, I'm going to ask, just in the interest of moving things along, if you can hold your questions to the end, and if you have them, write them down, and you can pass them to one of the volunteers, and then we can try to get through as many as possible. So let me go ahead and dive in. And I know a lot of you are aware of the Common Core. You know that it's been adopted by the state of California. But I want to give you a little bit of a quick background about why the Common Core. Not just what it is, but why are we even switching? Why not just keep doing what we've been doing? And I think that one of the sort of important takeaway points here is that the Common Core came about. It was not a federal initiative. It was actually the states got together, and before a single standard in K-12 was written, they went through a process. Essentially, they wanted to get a consensus document about what does it mean to be career and college ready. So the nature of this question was that they asked 10,000 plus individuals to give feedback on essentially an overriding question. And that is, for mathematics, which we'll be talking about today, the idea of what should a high school graduate know in mathematics and be able to use mathematically. Now, they didn't just ask mathematicians. I'm a mathematician, but I'm glad that they asked other people as well. In fact, they asked university professors, not just in mathematics and science, what mathematics do they want students to know and what they be able to use, but they also asked other fields, English, history, journalism, and they asked career pathways, the business sector. In your business or company, what would you look for a student to graduate high school knowing and being able to do mathematically? So this overriding question of what do we want high school graduates to know and be able to do mathematically, all of these responses, including career pathways such as nursing, criminal justice, you name it, all went in and were synthesized into a document that created what is called the Career and Readiness Standards, or a definition of what it means for a high school graduate to be ready for college or career. Only after that consensus document was made did the K-12 standards get written. And essentially, and we'll talk about this, they were sort of reverse engineered from this. So after the document of the career and college readiness, and then the K-12 standards were written, states were given the choice of whether adopting them or not. And as of, I have a more up-to-date version of this. It has not changed since November, but the end result is that essentially 43 states have adopted, and some of the territories have adopted as well, including, I I actually visited the Virgin Islands a couple years ago, and when I got off the airplane, there was a poster in the airport that said, "Welcome to the Virgin Islands. We've adopted the Common Core." So they're pretty proud of that. So most, by far, most of the states have adopted the Common Core. Of course, we're in California, and just to highlight that this was not just a sort of a state issue, I want to emphasize that unprecedented, a few months ago in August, end of August 2014, there was a statement issued, what's called the Higher Education Intersegmental Group. Essentially, California has 4 segments of higher education. Every single college and university belongs to one of these. In California, there's the UC system, there's the CSU system, and there's the community college system. Those 3 are the public higher education. And then the 4th segment is privates and independents. So in a very unprecedented sense, all 4 segments, every single higher education entity in the state of California signed a joint statement essentially expressing support of the Common Core. And in this letter, which you can download, it's online, it's publicly available, it says that not only do the universities support the Common Core, but this is what they are looking for the K-12 system to do in terms of rigorous preparation for the university, and that the admissions policies in each of these segments would reflect the Common Core. Because I know a lot of you as parents are thinking that that's one of the concerns you have. How will this impact my student in terms of not just learning mathematics, but going on to college, universities, and career? So the other thing I want to do before we dive in and get started is I want to just sort of highlight, there's 43 states that are currently implementing, and there's this whole sense of, when will be fully implemented. In fact, I've had parents come up to me and sort of say, the Common Core is ruining my child right now. And I just want to put this into a sort of reality check. And that is that from a student's perspective, the first time that the Common Core could be actually fully implemented would be a student graduating in 2024. So what I mean by this is that that's the earliest year that a student could have had a Common Core experience starting in kindergarten and graduating from high school. All students before that will necessarily have to have a hybrid of whatever was there before and then some Common Core experiences after. So just to put some numbers on this is, our last graduating class, congratulations. Class of 2014. Incidentally, my daughter was class of 2014. Even by, I'd say, conservative estimates, at best, this class had 7.692% of a Common Core experience. So in other words, I just want to put that in a sort of reality check. It's going to be time until, from a student's perspective, that we really have a sense of what will happen with this. And by this, I want to try to articulate a difference between these phrases, implementation and transition. We use the word implement a lot. Schools are implementing. The district is implementing. And this is more of a policy term. That means you can set up new courses and new pathways. And that's great. So you could, in some ways, be fully implemented from a policy perspective. But I just want to stress, from a student's perspective, and as parents of students, is that it's going to take time. The students right now in high school are going to have at most, 1-2 years of sort of Common Core experience before they graduate, because we've just started this. So this is more of a sense of a sort of reality. This is a transition, not just an implementation. And by transition, there's a question of sort of saying, like, transition to what? And what do we mean by Common Core? The phrase transition gives a sense of a sort of journey. here's where we're starting, wherever that is, and we want to somehow get to this vision of what we want to do. And so I think what's important is to note that what the Common Core standards are and what they are not. The Common Core standards are not a list of topics to be covered or taught. This idea of the Common Core as some sense a checklist, learn the Pythagorean theorem, know how to multiply fractions, etc., check. Rather, the Common Core is really a description of the mathematics students are expected to be able to understand and use. They're not a curriculum. They're actually the achievements made by students over the course of the year. So how are the Common Core state standards different than what we've had before? One thing to remember, especially in California, is it's been unprecedentedly long since there's been an update. On average, standards across the country last about 9 years. And I think that's interesting to note because the Common Core themselves are designed to have a 9-year revision cycle. So they are informed by research and evidence, and throughout the process, as we're implementing now, there will be revisions to improve them over time. No one is making the statement that somehow these are perfect, they should be carved in stone and never touched again. That said, the last time California adopted standards was in 1997. 15 years is a very sort of a long time in any state for a set of standards to be in place. So it's been a while since California has updated, revised, or modified. So that said, again, how is it different? Well, the one thing that I think makes the Common Core standards stand out is that they started with a definition of what it means for a high school graduate to be career and college ready. As I said, a consensus document with tens of thousands of input across the business and higher education communities, and reversed engineered it. So in other words, here's a target. This is what people are asking for out of a high school graduate. So if we want a student to graduate high school with this knowledge and skill set, then how do we get them there starting in kindergarten? And so there was 3 design principles: focus, coherence, and rigor. And with the target of career and college readiness, these were mapped backwards all the way down to kindergarten with the idea that students could start there and move. Focus was a response to the fact that most states in the U.S. had very long lists of standards in a given year. Compared internationally to other countries, and sometimes some grade levels would have twice as many standards, as many topics to be covered, so to speak. So part of this idea of focus was to get rid of this mile-wide, inch-deep phenomena. So the other part of this is coherence. By focusing on a smaller set of essential mathematical standards, selecting those that really built upon and would lead to other things, as opposed to sort of topics that kind of came and went, sort of a grab bag approach. And then lastly, the third design principle is rigor, which I will sort of get to. The other thing about the Common Core standards is that they have 2 equal parts. The first is the content standards, and the second is the practice standards. And I really do like to think of these as sort of the nouns and the verbs. The content standards are the what students are supposed to know. And the content standards are different for each year. In 3rd grade, there's certain content, which is different than 6th grade, which is different than 11th grade. On the other hand, the practices, if the content is the noun, the practices are the verbs. That's what students are supposed to be able to do and use. And the practices, and there's 8 of them, are the same 8 mathematical practices for every single grade. There's a footnote here that the other thing different, especially in comparison with the previous California standards, is their attention to real-life applications and mathematical modeling. The 8 mathematical practices, there they are. The one of the authors of the Common Core, Bill McCallum, wishes he had included this as a sort of way of organizing them in a sort of way that's easier to kind of communicate and wrap your head around. Essentially, the idea is students are supposed to be able to reason, explain, model, use tools, including technology like spreadsheets, graphing calculators, see structure, generalization, and then these overarching habits of mind, make sense of problems and persevere in solving them, and attend to precision. So, like I said, those 8 mathematical practices are the same in every single grade level. If you read the text of any one of them, they all start with the same phrase: mathematically proficient students can reason, can use tools, etc. So let's get back to this sort of question of rigor, because I think this is a key takeaway point when it comes down to what does it actually mean to transition to the Common Core, and how is this going to impact the experiences that your students are going to have in mathematics classes. Essentially, rigor as defined by the Common Core is comprised of 3 parts: procedural fluency, applications, and conceptual understanding. Now, this is the important aspect of this. These parts are to be treated with equal intensity. If you were to go on and look at the website, they break down what these are meant. I mean, so conceptual understanding is that students actually understand the concepts behind these procedures. Procedures, skills, and fluency, this is the ability to calculate, to use arithmetic, to manipulate and solve for X. Procedural skills and fluencies should be familiar because that's what the emphasis has been on across the country, really. And then lastly, this idea of applications. Now remember, this is rigor. So one of the pushbacks from the business community and universities is that essentially they've been getting students that are showing up, graduating from high school, that are procedurally fluent. In fact, can compute and calculate and do arithmetic better than ever. But the complaint is that many students don't understand the procedures, they cannot explain them, and more importantly, they cannot apply them or use them. And so the idea, and I don't think it's that controversial, is that if a student takes years of mathematics studies and doesn't really understand it or cannot use it to solve a problem arising in the workplace, then it kind of begs the question of, well, what's the point of teaching it? So the business community and the universities have been pushing back on some of the K-12 system and the state standards to say, look, we want students that have a balance. We want students that can compute and add and subtract and multiply and solve for X. That's great, but we want them to know what they're doing, be able to explain it, and be able to apply it. So just to make this sort of concrete, I mean, this is a sort of sample algebra worksheet. You know, simplify the following, expand the following. This should look familiar to some of you. You can't see it? Well, this is the way students see it. I see 2. I don't know if we could. I mean, it's not great, but I mean, again, we're not actually going to do this worksheet. This was more of an example. I mean, unless you want to. I mean, but part of this, I want to sort of, you know, this is almost a setup for some mathematical humor, which should be a warning. The main part shows up here. So this is a piece of student work, and Peter's being asked to expand a plus b to the n, and hopefully you can see that he's expanding it. I warned you, mathematical humor is a very specialized niche. There's limited entries in this category. But in this case, I mean, I share this because I also want to make a sort of point. I mean, if you talk to a lot of students, I mean, their impression of going through years of algebra is that it's moving letters and numbers around. I mean, that's expanding. I mean, why is that wrong? Or what is it you're supposed to do with that? Yeah, these are great. You're lucky. I was going to actually make you do this worksheet, but since you can't read it, we'll move on. But here's another example, and you can see that it's just, I mean, it's a lot of computations, but notice there's no context, there's nothing there. And in the sense of this idea that, hey, but what if kids need to solve something like this, x over x minus 1, etc. I mean, we actually live in an age where there is a lot of technology available. And this one's also hard to see, but that's okay. Wolfram Alpha. How many people know of this? It's an app on your phone. It's also free on the computers. It's really worth seeing. I mean, it will do all of this symbolic algebra. You can type in all of this stuff and it'll do it. And if you want to, you can't really see it, but it'll tell you step by step, like multiply both sides by x, subtract 5. It does all of this for you. I'm a professional mathematician, and I mean, the point of some of this balance between procedural fluency is that we want students to understand how to do this stuff, but we don't need to spend a lot of time doing things that technology can do better. So this gets back to this sort of idea of sort of answer getting. And this is an important point because, I mean, I have had parents ask me or actually tell me that I hear that the Common Core penalizes students for getting the right answer. That somehow, the Common Core is against correct answers. And that's not true. And let me go on record of saying the Common Core loves getting right answers as much as everybody loves it. What I think the confusion is this idea that getting the right answer is only part of the purpose. Getting the right answer, getting the answer correct is essential. But if you can't justify it or explain it, then that's not considered rigorous. A joke I like to say is that there's no job on the planet where you can walk into the CEO's office, write a number on the board, circle it, and then walk out. You're going to be asked, where did that come from? How did you get that? Make an argument. How can I believe that this is correct? You need to be able to back it up. That's the generalizable skill that we're looking for. So again, to emphasize it, getting correct answers is necessary, but students also must be able to understand it, explain it, and apply it. This is what we mean by rigor. And that's the sort of expectation for these changes. The previous standards, well, let's just take a little look, though I'm sad because I don't think they're showing up so well. Well, that's okay. So, I mean, in California, this is STAR test, 5th grade. Multiply, divide. Here's one from algebra. Again, solve for x, simplify the expression. Here's one more. Here's another algebra set of things. Solve this equation. What's the solution to this equation? These should look familiar. If you were making a movie and you wanted to film a scene in a math classroom, this is what you'd write on the board so everyone in the audience would go, oh, that's a math classroom, right? But here's the sort of deal. Students are not going to be given assessments that look just like this anymore. Lots of multiple choice test questions that have, essentially computational basis. Why are they not going to be these? Again, it's not because Common Core is against solving equations. It's because this is not rigorous. This is not enough. All of these are essentially procedural in nature. None of these questions really get at conceptual understanding, and none of them are applications in a real sense. So remember, the business communities, the universities want students to understand and be able to apply mathematics. That's the real shift. Just to underscore this, here's a nice little, this has been circulating around. This was the, from 1970, the Fortune 500 companies asked about their most valued skills. If you look, writing and computation skills were number one. Ooh, wow. It's kind of romantic all of a sudden. So in 1970, I mean, computational skills, writing skills, those were huge. In 1999, turn of the century, teamwork, problem solving, interpersonal skills. Notice computational skills don't even make the top 10. So again, just to be clear, I'm not saying that computation is not part of mathematics. What I'm saying is that for the past 15 years, we've had an overemphasis on that at the expense of understanding and application. So that's what we're trying to shift. And where is this coming from? It's coming from business, industries, and universities. I actually sit on the STEM advisory board for UC Berkeley. And I know that some of you in this room are thinking, well, you know, this all sounds fine, but you know, what about getting into, say, Berkeley or Stanford or Harvard? What if my son or daughter wants to be an engineer or a mathematician? The thing to know, and at least, you know, I'll speak with some knowledge from the trying to get into, say, UC Berkeley. This is a website. You can go on and see how Berkeley selects its students. And getting into the elite universities, at least at Berkeley, involves a holistic review. It's called comprehensive admissions, and there's 10 sort of dimensions, and students are given sort of points on all of these dimensions. The one thing I can tell you is that there is not a spreadsheet where you put in where Berkeley lists the GPAs and then presses sort, and then draws a line and says, hey, these kids have the highest GPA, they get in. That's not how. In the past, that was more true, definitely, but the entire UC system has switched to what's called comprehensive admissions. So these ideas of sorting on that or an SAT score is just not what happens anymore. However, I mean, just to make sure that, you know, and I know it's a little hard to read, but I mean, I'll read it for you. The first dimension of the holistic review is the applicant's full record of achievement in college preparatory work and high school, including the number and rigor of courses taken and the grades earned. So, yes, this is not a surprise. The universities look closely at the high school transcript. But here's the thing that's going to be looked at. It's in the process of being looked at, and this is this phrase here, number and rigor of courses taken. I keep going back to the Common Core is about changing the definition of what it means to be mathematically proficient, what it means to be a rigorous mathematics preparation. One thing I want to also go on record of saying, of course, the University of California has been around for over 100 years. The Common Core and the standards before it and the standards before that. The UC system doesn't see themselves as really responding per se to the Common Core. They look more broadly at their mission in education. As such, on their website, what they plan to do is actually unpack this notion of rigor. In other words, to shape and inform what we mean by rigor in high school classrooms. And again, just to sort of emphasize this, it's about this balance. So the universities are looking for this too. So the key idea here is that the Common Core is not shuffling some topics around. It's not making Algebra 1 in 8th grade instead of 9th grade. It's not moving when the Pythagorean theorem is being taught. I mean, yes, some topics are moving around, but that is a minor aspect of it. Really, the Common Core is about changing the definition of what does it mean to be mathematically proficient, and that the Common Core itself is a response to the demands from colleges and the business sector to change what is meant by rigorous mathematics. A not very great graphic to sort of demonstrate this is that we used to have, at least in California, but most states were very similar, a more a more narrow focus. So the target that we are aiming students at was more procedural fluency based. The new definition is broader. It includes procedural fluency, but it also includes applications and conceptual understanding. All right? So if, that to me is really the sort of the idea of this shift that when we're talking about shifting to Common Core, that's what we're looking for. How are kids going to be assessed? I mean, one of these is that, well, some of you may or may not be aware, there's 2 consortia in the U.S. About half the states, I think 26 of them, are with Smarter Balance, and the other ones are with what's called the PARC Consortium. California is part of the Smarter Balanced Assessment Consortia. And I just want to spend just a minute or two talking about the shifts that are taking place and the way students will be assessed. One of these is that I think it's important. I pointed out the previous STAR testing and the California high school exit exam. These were fixed form, sort of multiple choice based questions. Students answered, say, 70 questions, and they got a percentage right. So say they got 70% right. One of the things is that it's natural to ask the question of, well, what does that mean? What can that student do mathematically? I mean, it means they got 70% of the questions right. Does it mean that they can apply their knowledge? Does it mean they're good at solving equations? We actually really, you can't really unpack those numbers very well. The Smarter Balance, though, students are not going to get a score in algebra or geometry. All students are going to be reported on these 4 claims. And all of these claims are phrased in the sense students can explain and apply mathematical concepts and carry out mathematical procedures with fluency and precision. Claim 2, students can solve problems. 3, students can communicate reasonings. Claim 4, students can analyze complex real-world scenarios and construct mathematical models. So all of these are claims of what students are capable of doing. So what we're looking for in assessing, and I'm on the item quality review panel, is when we look at these math questions, we don't just look at is that mathematically accurate or not. We ask this question: if a student was to get this question right, would this provide strong evidence of any of these claims? So if you want to think about the paradigm shift in assessment, the assessments are not going to be about what percentage your student got correct, but rather the new ones are the assessment is going to try to make a case for what your student is proficient at in these 4 categories. It's computer adaptive, which means students will get different questions to better maximize the opportunities to showcase what the student is capable of doing. So again, I'm going to show an example. This is not a great example, but I like it because it allows me to sort of highlight a couple points about the way the shift in Smarter Balance is going. So, before you jump on this as saying, that's not a very good test question, let's just bear this out. So, Jamal is filling bags with sand. All the bags are the same size. This one I want you to do along with me, so try to solve it in your head. All right, so each bag must weigh less than 50 pounds. So one sandbag weighs 57 and the other weighs 41 pounds. Explain whether Jamal can pour sand from one bag into the other so the weight of each bag is less than 50. So first of all, let me just highlight, remember the Smarter Balance is about trying to engage students with real life applications, and students love filling sandbags. Students find this very engaging. I'm being sarcastic. I'm always afraid if a transcript of this comes out, they're going to say wow, is he serious? Do kids really like filling bags with sand that much? not so much. It is what it is. I would say that it's a meaningful context in the sense that you can make sense of it. And although some of you might have not had to take a math test in a while, some of you are probably going, well, hey, all right, I can figure this out. There's 57 pounds in one, so what if I just took 8 pounds from that bag? So that would mean there's 49 left. And then I took that 8 pounds and put it in the other that had 41, so 41 and 8. So I can get 49 in each bag. So that's less than 50, done. All right, there you go. That's not so hard. But what is the mathematics? So like I said, it's a sandbag problem. It's, not the most compelling thing in the world. But like I said, what is this actually evidence of? What would we think it is? Is this a procedure, or what are we trying to do? And furthermore, what grade level would this be? The operations are 1 and 2 digit whole numbers, adding and subtracting. Do you know what year that is usually taught in? 1 and 2 digit numbers, adding, subtracting? 2nd grade, yeah. So what's interesting is that this is actually a 6th grade problem. Now, so first of all, you're going, oh my God, the Common Core is so easy. Now I'm worried that it's not rigorous enough. How are my kids going to get into Berkeley now? Well, here's the point. Notice the claim, you can read that. This is, if a student gets this right, we would say that it's evidence of claim 2, problem solving. Why is it evidence of problem solving? Well, to highlight this, the reason is that presumably no student has memorized a formula for filling sandbags. A procedural problem means for example, if there existed this formula that I could just plug in the number and it would spit out the solution, that's using a procedure. Plugging into a number, to find, for example, the quadratic equation to find the roots, that is a procedure. Since no memorized formulas or procedures exist, that means the students have to read it and come up with what mathematics am I supposed to use to be able to solve this. Notice that the solution I gave is not even the only one. There's others that you could do. So that's what makes it problem solving. And one of the things we found is that a lot of students, even students that are getting straight A's and have gotten a 5 on AP Calculus, are showing up at universities in engineering classes and essentially being stymied by, well, not this level, but similar things where they read it and say, I don't know, am I supposed to take a derivative, an integral? I'm not sure. So this idea of understanding is so essential. The other thing here is that the reason I like to share this example is not to sort of, why the easy numbers? And remember, I could have made this problem a lot harder by just putting nasty things in. Instead of 57 pounds, I could have made it like 57.29374, or I could have had decimals, fractions, and whatnot. And we know that a lot of students who have trouble with some of those numeric fluency would stumble on this. But the point is that we're trying to collect evidence that they can read and make sense of a situation. We have separate questions to see if they can add, multiply, and divide. Remember, there's 4 claims. The claim 1 is the procedural fluency. What this means is that in spite of having a broader definition, imagine that kid who is creative, innovative, can come up with ways of solving problems, can look at situations and come up with analyses and be able to communicate approaches, but division of fractions messes them up, or long division of decimals. So arithmetic can get in the way of kids that have creativity, innovation, and analytic skills. I myself am not particularly good at arithmetic, and that did not hold me back from getting a PhD in mathematics. Our system has really, unfortunately, had the impact of holding a lot of students back from mathematical proficiency. Again, let me stress, I'm not saying that students do not need to be able to know what decimals and fractions are, but in the past, students that struggled with some basic arithmetic were denied opportunities to do anything else. All of that is trying to broaden this, because at the end of the day, when you're in the real world, when you're working on an engineering bridge, people are not going to be doing the computations by hand with pencil and paper. They have the number sense to check, but they'll be using calculators and computers, and they'll be able to understand it to be able to make sure they didn't type it in wrong or whatnot. That's what we're sort of looking for. So again, I want to highlight this sort of question about, okay, there's these shifts. I see the Smarter Balance is going to be asking more word problems and things that students are going to not just be able to memorize, they're going to have to think and read, which, by the way, when you ask kids about how they think about the Common Core, a lot of kids will report that they don't like it because they have to think and read. So unfortunately, that is true. They do have to think and read. Some of you may or may not be aware that the SAT is being redesigned. There's a new SAT coming out in 2016. And this is from the SAT's website. The focus will be on math that matters most. And they say the focus will be on 3 essential areas of math: problem solving and data analysis, the heart of algebra, and passport to advanced mathematics. And so if you're wondering about the heart of mathematics, in this case, what they mean is linear and exponential functions. That a lot of situations that we encounter are typically either linear, proportional type things, or exponential, multiplicative. So that's the heart of algebra. The further, if you go on their website, and again, I apologize, I'll kind of read this. Throughout the redesign SAT, students will engage with questions grounded in the real world, questions directly related to the work performed in college and career. There's that phrase, college and career. So is SAT actually assessing the Common Core now? No, absolutely not. The SAT, much like Berkeley and other universities, they're their own entity. The SAT has never assessed any given state's standards or a particular curriculum. The SAT is the SAT. But in this case, the redesigned SAT, that phrase, career and college, there is a relationship. They look to the same document of defining, the consensus document about what does businesses and universities want in career and college readiness. And so they have used that to help shape the redesign. Remember, the SAT's client, the SAT's purpose, its reason for existing is helping provide analysis of students' readiness for college to colleges. That's its purpose. So when the colleges are saying, we would actually like students that can do these sorts of things, the SAT has responded. So in some ways, I want to be clear that the SAT, the new redesign, is not testing the Common Core, but it is related in the sense that they're both informed by this consensus document about career and college readiness. And here at the bottom, the math section will feature multi-step applications to solve problems in science, social science, career scenarios, other real-life contexts. Students will be presented with a scenario and then asked several questions about it. This allows students to dig into a situation and think about it and model it mathematically. So other countries talk about quantitative literacy. This is this idea of being able to read a story or read a situation, some data, and then be able to analyze it quantitatively and mathematically and answer questions about it. The SAT questions, here's one about diving below salt water and the certain amount of pressure, the deeper you go. And again, instead of solving an equation, what they're more interested in is, can you set up the relationship between the pressure on the diver as a function of the depth? So if you remember your own high school math days, or if you've been helping your students recently, the part that most students today typically find, they don't like word problems because they don't like reading it, making sense of it, and setting up the equations to solve. Give me the equation, I have a procedure, I can solve it. But what this shift is that we actually want to assess kids on can they set them up, can they make sense of it. Here's another, these are all from the SAT website, by the way. Here's one about a survey with voting turnout rates in different age groups, and there's a whole series of questions. Can you read this chart, table, make sense of it? So I've tried to bounce back and forth between Smarter Balance, SAT, what the universities and admissions are doing, and what does this all mean? And I want to sort of end tonight with this sort of idea that all of these are new expectations for students, and these are going to require new pathways. And I'll just sort of highlight one example of some of the complexity that many districts are struggling with across the country. And this is from the California framework, where essentially they say there's a vocabulary problem. In California, at least, there used to be a course called Algebra 1 that was mostly an 8th grade class. However, in Common Core, there's a course called Algebra 1 that is a 9th grade course. And just to, if you can't read all of this, I'll just highlight confusion, Algebra 1, confusion, Algebra 1. This has caused more confusions than just about anything in this transition process. I, as a mathematician, have summed it up even more neatly by this inequality. What used to be called Algebra 1 for the last 15 years, that SAT in 8th grade in California, is just a completely different course than what is the Algebra 1 that is a 9th grade high school Common Core course. In fact, if you had to say what the old California Algebra 1 was most like, it was probably most like Common Core grade 8. So it's incredibly confusing. You probably have situations where you have a student right now who is taking a Algebra 1 course in 8th grade, and what might actually make sense is for them to take Algebra 1 in 9th grade, because it's a different course entirely. So, I mean, just to emphasize this more, and yeah, none of these are very legible, but 8th grade California standards had, I'll read some of these: add and subtract systems of equations, apply second and third degree polynomials, simplify fractions with polynomials in the numerators and denominators. These are all what 8th graders were supposed to do. So there's something called a crosswalk, where you take the list of standards from the old standards and then you map them and see where they appear in the new standards. That's a crosswalk. And my point is that that's just not the answer. This whole Algebra 1 thing is so confusing that if you were to look at the topics in the old California Algebra 1 8th grade class, that some of those topics are in 6th grade Common Core, some are in 7th, 8th, 9th, 10th, and 11th. That 1 year of algebra, California, has been spread out across 6 years. So, and by spreading it out, that means some of it is before, some of it's after. So it's not even this question of one's, quote, harder or more rigorous than the other. They're just different. The author of the Common Core said, if algebra is universally seen as so important, why pack it into 1 year? Why not do it over 6 years and get a firm foundation? So this gets us to this sort of point that the other takeaway, as schools are grappling with this, and you as parents, is that we used to have, remember my little visual of the procedural target? If the target was procedural, speed and accuracy of computations, guess what? There was some kids that just were a lot faster. And if you're in a class that's focused on that, the likelihood is that if you're fast and accurate, you're going to be bored. I mean, it's not very exciting to sit around being done and looking at other kids compute more slowly than you. I mean, it's not fun. Actually, watching kids compute in general is not always that exciting for anyone. But for these kids, what we did in California is we responded. We want all kids to be challenged. And so if they're sitting there in 6th grade and they're bored because they can compute quickly and accurately, how did the system respond? We pulled high school courses down into middle school for them to do, effectively skipping or accelerating middle school. so that they could get to the more advanced high school topics. So, but the thing is that that was based on the assumption that we were looking at a certain definition of rigor and proficiency. So if your definition of proficiency is procedural, then it makes sense to pull in these advanced classes. The Common Core takes a different approach. It actually expands the definition of rigor, and it makes the content less skippable, so to speak, technical term. Here's a map of the Common Core topics in grade 8. This is one of the things that a lot of people who are used to taking Algebra 1 in grade 8 are saying, we want Algebra 1. We want to skip this. But this really is mostly what was in Algebra 1. Exponents, scientific notation, geometry, similarity, 3D geometry, linear functions, systems of linear equations, Pythagorean theorems, statistics, scatter plots, functions. This is a very rigorous class. So the California framework has been saying very clearly, decisions to accelerate students in Common Core before 9th grade should not be rushed. Placing students in accelerated pathways too early should be avoided. So I just want to go back. I mean, what it means to be successful at mathematics is not getting as far ahead as you can, but it means mastering rigorous mathematics. But I want to close at this point with a sense that hopefully will help ease some of your concerns. And that is that although we've talked about rigorous mathematics and changing these sort of pathways, I want to highlight that there's one important thing, and that is the outcome. And these are just, I'm going to show you 2 samples of pathways, but essentially, in theory, what we've been saying is don't rush through middle school. Middle school is very important mathematics. But this chart, which I guess is really hard to read, these slides will be made available. Anyone who wants to can have copies of them. But essentially, this picture up here, this is what most of the schools in California have been doing. And you can't read it, but it actually says old grade 6, old grade 7, Algebra 1 in 8th grade, and then in 9th grade it would be geometry, 10th grade Algebra 2, 11th pre-calc, and then 12th AP Calculus. That's what most of the students have been doing in California. The advanced students have skipped. So they'll take Algebra 1 in 7th grade, and then geometry in 8th grade, and then they can do Algebra 2 in 9th, and then they can do pre-calculus, and then they can take AP Calc AB and AP Calc BC. That constitutes what most of the students have been doing. I just want you to pay attention to the advanced options at the end. Here are 2 Common Core pathways, and notice the top one is what we expect most students to do, has as an outcome AP Calculus or statistics in the 12th grade, just like before. And then the bottom choice is AP Calc, 2 years of AP Calc, and by the way, it could also be AP Calc 1 year and AP Statistics the other. So as parents, I know you're worried that somehow the Common Core might be shutting down or closing the door on your students and denying them opportunities for advanced mathematics classes. What I'm trying to point out is that with the shift in definition and the shift of expectations, the one thing I hope you notice about the top line and the third line is that instead of eating away at the middle school, we can have students at grade level get a solid foundation in middle school and get to the exact same place that they were before. And so that's really, and this is one where they sort of skip 6th grade. Here's one that's so-called where you compress 7th and 8th grade, and in this one you see that you almost preserve all of middle school as a solid foundation. So I know that as you're looking at this, you're saying, wait, how is that possible? How can you stay at grade level and get to AP Calculus? In the past, we had to move high school down. We had to move that algebra down because there wasn't enough courses. So you've probably figured out the magic here. The Common Core actually takes the topics of pre-calculus and weaves it from middle school through 11th grade. A student who is successful and getting A's in a rigorous Common Core class, it would be redundant for them to take pre-calculus. Those of you who are familiar with the topics, it's mostly because of functions, which is in an equations-based system that we've had before. Students need functions understanding to do calculus. That's woven from middle school on in the Common Core. So those are the sorts of shifts that have happened. So let me just end by saying that, I just want to, I have 4 kids of my own, so I'm sort of living the game as well. And I can tell you that I'm excited about this, and that I want you to leave here today, hopefully, with a sense that there's a reason, a rationale for this. I want to acknowledge that transitions are like home remodels. I mean, they're messy, and there's schools and your teachers are working incredibly hard to try to make this transition as smooth as possible. Every individual student, we don't want anyone to fall through the cracks, everyone to be challenged, everyone to be given the opportunities, and there is a vision in place. And so hopefully this, and as I said, for those who have students that were worried that the Common Core would not provide access to advanced mathematics, and that there's the desire that using the same assumptions that we need to sort of rush through the middle school, I hope that this gave some argument for why you can get to the exact same place in terms of advanced mathematics courses for as a student without doing that, and actually laying down that broader foundation. So I'll just go ahead and stop there. One of the questions I'm sure will come up is there anything as a parent that I could look at? Is there any websites I could go to? Here's 3 that I highly recommend. So you can copy those down. And now, we have a few minutes for questions. And while they're doing this, I know that you have, if you Google Common Core, let's just say you'll get a lot of stuff. In fact, I mean, to be honest, you'll get a lot of stuff, so much stuff, and a lot of it is just crazy. So these, I think, instead of just randomly Googling like Common Core algebra, these have resources for parents, these have examples, videos, how to support your students, etc. Do you want to kind of filter some of these for me? With Common Core, will calculus and statistics be 12th grade math class? So that's a good question. Common Core actually only describes 3 years of mathematics in high school. That 4th year is open for a lot of options. Calculus is one of them, statistics is one of them, but there's also the idea of sort of career tech math classes. So different districts are doing different things. I think a lot of universities really encourage all students having 4 years of mathematics, but that 4th year doesn't necessarily have to be calculus. Yeah. Wait, you can't read it, and then you're handing it to me? What happens with 7th and 8th grade advanced? Well, my 6th grader not offered 7th grade math as an option. 6th grade. Oh, right. So hopefully those charts I was showing is that there's different options available. Some 6th graders are being offered 7th grade. The preference that the state has is that instead of skipping a grade, it's called compressing. And so kids could do, in some cases, a 6-7 combo, 3 years and 2 years, or doing 6 and then a 7th, 8th. There's a lot of things. The idea of why compressing instead of skipping, and that is that the Common Core is designed with a certain amount of coherence. And so instead of missing or having gaps, certain students may be able to move a little bit more quickly. But again, the goal isn't to race through this. The goal is to actually have a depth of understanding. Why are high school students only tested in the 11th grade and not tested every year like the elementary and middle school grades? Well, that's a good question. I think the main reason is because of the fact that the Common Core left as an option, and California as a state left as an option, integrated or traditional pathways. In other words, you could do an Algebra 1 Geometry, Algebra 2, that's what's called traditional, or integrated 1, 2, 3. Just for clarity, they're the exact same standards, just organized differently into courses. They are not different standards, just different sequencing. As such, Smarter Balanced would rather just test all students in sort of with one assessment rather than making different versions. I'll say that if you move to another state that's a park state, they have 2 different versions and they test in 9th, 10th, and 11th. I personally like the idea of only testing once in 11th. I mean, we have plenty of testing, but to me, I think it also sends the message to 9th and 10th grade teachers, we don't want to teach students to be good at something at the end of the year and then forget it over the summer. We want to teach for long-term understanding and retention. So in some ways, by having an 11th grade exam that assesses 3 years of mathematics, that has implications for how the courses need to be taught. How does UC Berkeley examine the rigor of high school courses? So that's a very good question. They are in the process of revising what's called the A through G, approval. I don't think that's the right word. All schools in California essentially have to go through a process to get authorized that their courses are rigorous and for college credit. The UC system is in the process of changing this to align with the notions of rigor right now. So all these courses, every single high school, every district will have to submit documentation showing how it's rigorous, and then UC decides whether that counts or not. So a course that doesn't include applications and conceptual understanding in a clear way will not be approved as rigorous. So Kendra was just asking a question that had come up earlier that gets asked a lot, and this is related to honors and the way that the UC system looks at it. Is it better to take a honors course and get a B versus a regular course and get an A? It's a good question. I asked and was told it depends. In general, it would be considered a wash in terms of admissions to UC. However, the idea is that in the comprehensive admissions, it's not just a cut and dry which classes and which grades you took, but it looks actually at the sequence. So in other words, the answer is what makes sense for an individual learner in terms of long-term gains. Just to give you like a concrete example, a student who took a bunch of math classes, accelerated and got to AP Calculus in 10th grade, but did not take any math in 11th or 12th grade, would not be seen as better than someone who stayed at grade level and took AP Calculus in 12th grade. The one thing I can tell you, this idea is like earlier and the better, it somehow gets extra points is just not true. So the idea is that they look at it across the board and say, here it looks like a sequence of rigorous courses that is leading towards the objective that the students are describing. They want to be an engineer, they take 4 years of math, and for some students, if they're taking an honors class and getting a B, that makes sense. Some taking a regular class and taking A makes sense. So the answer is that it's sort of a wash. Not one of those scenarios is automatically considered better than the other. What is the path for 7th grade students that are already taking California 8th grade algebra? Repeat, what if they already get it? So again, I have to, I can't speak to the exact details that are happening here in Huntington Beach. Every district is making their own choices. I can tell you that some districts are choosing to encourage students that are taking this is saying if they're already taking the Common Core 8th grade Algebra 1. In 7th grade. So essentially, if I had to say in a nutshell, in general, what we want to do is have kids be successful at grade level. So in 8th grade, they should be doing Common Core 8th grade. If a student can show mastery of a rigorous mathematics, then as in the past, I keep saying that we don't want to skip or accelerate it, but please understand that there are certain students, individuals, that this makes sense for. And so, but the case is that in the past we've tended to sort of put large numbers of students into these sort of so-called accelerated pathways. Some of those, probably shouldn't have been in those pathways. So right now the big shift is that if a student can demonstrate that they have conceptual understanding and that they can apply their knowledge and they can do all of these things that I've mentioned, then they will be considered on a case-by-case basis. So, I mean, in terms of this, I wouldn't be able to answer the specifics for this particular district, but in general, that's what most places are trying to do. And again, let me just re-emphasize, the names of these courses and the labels are very confusing. What the schools are trying to do is actually help students be put into the course where they will have the best opportunity to learn the best that they can and be set up in a pathway that gets them to go towards their career or college that they are trying to get to. That's the goal. That's what the systems are trying to work for. And in the meantime, some of these things about like which one is Algebra 1 and this honors versus that one is definitely, this is that remodel process. As a parent, I'm sure that you have questions, but the goal here is to ask at your individual school, what are the criteria, what is happening, what are these sort of pathways, and remember just the big picture. All right, I guess yours was the one, let me see. If I can read this, I love the idea of making students see the different ways of doing things. However, why penalize them for not seeing these different ways when they have the answers correct, especially when these students are getting the hybrid system right now? Oh, okay. So did I capture that? So one of the things about seeing things different ways, I would characterize it more as having a sort of a rigorous understanding in the fact that what we have is that students are not being penalized for getting the correct answers. What we're saying is that that's just, if you can get the correct answer, but you also need to be able to explain it, not necessarily see it in a different way. I mean, the idea is being able to justify or make a case. So this is hopefully this sort of idea that no one, if we can walk out of here with this, no student is ever should be penalized for getting the right answer. That just should never happen. On the other hand, what we're saying is that we want students to get the right answer and be able to apply it and be able to communicate it. So that's what I want to make sure is clear.
Some of the questions that were bypassed, they are very specific to our school district that Dr. Callahan will not be able to answer. And so if you did not hear your question, that was the reason it was filtered.
Yeah, and I wanted, and also just in interest of time, it's 7:10, and I know that all of you have very busy lives and many things to do. I just want to say thank you, Kendra. And again, we didn't answer some of these that are very specific to a particular school or site or student or teacher. I was trying to answer the more broad questions. But I encourage, especially if you have specific questions, Kendra will collect these and others, and we'll try to do our best to make sure that all of your concerns and questions get answered. But at this point, I think I would like to just be mindful and thank you all for coming out on this rainy night, and hopefully this was helpful. Thank you.